Hi, I'm Anton from Anton's MindStorms Hacks. In this video, I'm going to explain how to use a motor as a touch sensor. In my review of the Robot Inventor set, I claimed that a touch sensor or a force sensor, like you get one in the Spike Prime kit, is an unnecessary piece of equipment because you can use a motor as touch sensor. And in this video, I'm going to explain you how to do that. I'm going to use a spike motor for it, so you can see it's the blue kind and not the gray kind that are in the Robot Inventor set, because I have JLo here and I don't want to disassemble JLo yet. I'm still playing with JLo, still developing Python scripts. So I'm going to use a Spike Prime motor and a Spike Prime hub and the Spike Prime software, but the word blocks and the code and the thinking is exactly the same for LEGO Mindstorms. The only difference is that it all got a white background instead of a black background. The touch sensor that I've built is really simple. It's this kind of gray cross part, 2 blue pins, and it's got a little brown axle with a stop and a ball bearing. So these are all parts from the Robot Inventor kit. They do not come with the Spike Prime kit. And so this is one part, and then I have this axle and these 2 long axles that I'm using here in the motor, and I'm using that to create a bar. And now I have a linear actuator, so I can press this and it will rotate the motor. The problem is now that once I press it, it doesn't come back. So we will need some programming there. That's what we are going to do right now. I have put the motor into port F here, and so you can see if I rotate it, this value changes. Now this, for the simplest possible button, we can use the event head block, and we're not going to use the start block. You can use it of course in your own program. However, we're just going to watch the event here, and we are going to check if the motor position, so right now it is at 27, I have fully pressed it, can't press it any further. So let's say if it's beyond 24, let's have a 3-degree play in there. Let's get the position, F position. Now it's pressed. Well, in that case, we are going to rotate it back to 0. Now, completely up is 355. So yeah, let's give it a few degrees play. Once we press it, we rotate it back up, and we can also make a little happy face here to show that it's pressed. And if we do this, we also have to turn off the happy face if it's not pressed. So we use the not operator for that, and all of this. So if this happens, either this or that happens because of the not. And in that case, we're just going to turn off the light, turn off pixels. Okay, let's try this program and see if we did everything right. Okay, there is a mistake. The motor doesn't come back nicely, and the happy face shows in the wrong situation. I think we made a programming mistake. Let's see what we did. Yes. So, the programming mistake that we made here is that we checked if f was larger than 24, but when f is beyond 0, it goes up to 356, so that's also larger than 24. That doesn't work. So what we have to do here is use the between operator. Now, if the position of F is between 24 and say 100, or 50, doesn't really matter as long as it's not 300, that's when we are going to show the happy face. And when it's not in that range, apparently it's not pressed, then we are going to turn off the pixels. So this will work better. So this is a between operator. Let's try that. Okay, this is better, but I'm not seeing the happy face long enough. I think I set the range too tight, so I'm going to expand the range. I think 24 was too narrow. Once it starts pushing back, the pixels are turned off. So I'm going to decrease the range here a bit. Let's say up to 19. Let's count that as pressed, and otherwise it's depressed. Run that again. Okay, now we have a nice touch sensor. It shows a happy face if you press it, and if you release it, it hides the happy face. So we made a touch sensor with a motor. Problem here is that I think it's very tough to press. So in sensitive mechanisms, this probably will not work. And for this, we are going to use a different approach. So instead of looking at the events, let's make a new program here. We can look at the position of F all the time. And what I also don't like is the fact that the F here, it goes over to 356 degrees because it goes beyond 0, and that makes the program a bit hard to do. So I'm going to use the more motor blocks and the relative position here. So F also has a relative position, which is easier to work with in this case. Now, the first thing we should do is set the relative position to 0 in the uppermost position of the switch. So for that, we are going to start the motor F with it says speed. I need the power block. Speed tries to control the speed, and the power block is much simpler. It just controls the voltage. So I want to run at minus 20% of the voltage. Half a second should be enough to move it all the way up. And once that's done, I want to reset the relative position to 0. Now we have zeroed our F motor, and then we can start watching it. I'm just going to run this program here quickly and stop it. So F is now at 0. Now we can start watching F and pushing F back to 0 if we push it away from 0. For this, we are going to start F at a certain power, and the power that we are going to use is dependent on the amount of degrees F is away from 0. So we are going to multiply the degrees it is away from 0, so that's the relative position here, the relative position of F. And if F is 20 degrees away from 0, if we put -1, this will make it minus 20% power it will push it back to 0 with minus 20% power. That's okay, but I want to increase this a bit, to increase the power a bit. And so this program now sets F to 0 and then goes in this loop and forever tries to push push F back to 0. Now we have in effect built a force sensor. Let's run this program and see what happens. Okay. So this is a bit more reliable than the other option because I can always be sure that F is pushed back. And we can still do the happy face thing. So let's still do the happy face thing. Stop the program. We can still make the head blocks here and check if F is the relative position is above what was it, 20? Let's do the happy face thing. So either it's above 20 or it's not above 20, and in either case we can either show the happy face or turn off the pixels. Try this. Okay, so this is a pretty reliable touch sensor, but still I think it's rather tough to press. So let's see if we can fix that. Because F is so tough to press, what we can do is also, here we are pressing F back, but we can also help F. So we can make another control loop, repeat until, and repeat until the relative position has gone over. What's the total depression? Oh, it's actually going up to 35. So I think we can increase this number to 25 here, then we have a 10-degree play. So while F is not over 25, we can actually help F and give it a little positive power. So it will be easier to depress, and once it's gone beyond that, we will push F back up. Like this, and put this into a forever loop. This might not work because this is also, it will never exit this loop. So we should probably check if I'm too lazy. So instead of changing the direction here, you cannot change the direction, which is a little sad. So I'm just swapping places. So once F is smaller than, say, I don't know, 4 or something, that should be okay. Then we don't need to push it back anymore. Let's see if we now have a button that pushes easier. Okay. Now it's really soft to the touch. It's maybe hard to capture that on video, but I really have to, I can touch it really lightly and it goes in and then it comes back. So what this program does, it helps me push it in, and once it's completely pressed, it starts pushing back. So now I have made a very, very light touch sensor, and this touch sensor is actually better than the spike prime touch sensor because you can't change the spring in there, and here we have a programmable spring in our touch sensor, and it's really light to press. Okay, let's stop this program. The next thing I want to do is make a different kind of touch sensor or button, and I want to make a switch. So we can not only make a depressible button, but we can also make a switch, so that dependent on we can maybe switch something on or off, and we can make a little program that makes sure that the motor is either here or there, but never in between. And so this will be like a toggling switch. So that's also a nice kind of switch to have. Let's try and program that. Make a new program for our switch. To program the switch, we will probably have to detect if it's in either position. So I'm going to use a different trick here for zeroing the relative position. What I'm going to do is use the absolute encoder to reset the relative encoder. For this, I'm going to go here. For this, I need to set the relative position, and well, if I would input the absolute encoder position, we're still using motor F here, that would work only if it's above 0, but if it's on the other side of 0, this number will be in the 350 something, and that's not so nice. I want a number that is 0 when the switch is up straight, a negative when the switch is to one side, and positive when the switch is to the other side. So we'll have to do some math here with this number, and the math involved is, it's actually not so mathematical. So we're just going to check if the position is over 180, like this. Operators, if it is over 180, we're going to do one thing. If it's not over 180, we can just put it in here simple. If it's over 180, we will have to subtract 360 from it. And then we will have our negative number. Let's try this. Let's try this program. This is not very spectacular. However, what we did is we zeroed the F. So now I can show you on the model. If I put the model up straight, like this, my motor F, and that's the relative position here. I'll show you. I'm showing the relative position, and the relative position is now identical to the absolute position, except that it goes over back to negative numbers. So this is a very handy trick to calibrate your relative encoder to your absolute encoder. It's a trick that I use in many programs. Now, once we have found our 0 for the relative encoder, we can put all of this into a forever control loop, and in this control loop, we are going to test if our switch is to one side or if it's to the other side. And that's going to be like this. If F is by now above 2024, if the relative position, let's get our relative position here, is above 24. Let's make it 22. In that case, I have to make sure to choose the right positions here. In that case, I'm just going to stop the motor because we are at a right position. If it's not at that position, we're going to try something else. Maybe it's on the other side, so maybe it's beyond -22. In that case, I'm also going to stop the motor. We can even make a nice image on the display. Say this is one side and this is the other side. Okay, so this will show us the switch position. Now, if it's on our side, we can stop the motor and turn on the display. In the other cases, we should be running our motors. So we are going to check the speeds. If the speed of motor F is positive, so it's above 0, motor F, yes, then we are going to start our motor at some power. Full power, let's try full power. And duplicate this whole thing. If it's got a negative speed, so we can switch this around. So if 0 is larger than the speed of F, or if F is smaller than 0, the speed is below 0, then we will start it with a negative voltage. And let's have a look at this program. Okay, so the display shows what we want to know, and make it a bit clearer like this. Okay, and my switch with a light touch here, it goes from one side to the other side. So now I have created a flip-flop on-off switch with a motor. And well, I hope this video shows you how motors are much more versatile as switches and touch sensors and force sensors than the Spike Prime included force sensor. You just don't need it. I used the force sensor a lot on EV3 to reset motor positions, but with the absolute encoders in here, you don't need the touch sensor anymore to reset motor positions. The only thing is probably user interface. So you can make these nice switches here. So it's still running. You can even soften the spring with some code. So this is all very versatile. And you can even use the hub here because it's got an accelerometer. You can tap it, and this is also counting as a user interface element. So on this set, you will not miss the touch sensor. Okay, I hope you enjoyed this video. You learned something about scratch blocks, and I'm looking forward to seeing your robots with this smart motor-based touch sensor inside. If you like this video, consider supporting me on Patreon. The more supporters I have, the more time I can dedicate to making these tutorial videos. And remember to subscribe down here. If I release more Mindstorms or Spike Prime tutorials, you will be the first one to know. I think one of the next videos I'm going to make is a video to show you how to put numbers up to 100 on a 5x5 display. That's really awesome. Thanks for watching. Bye bye.